Alright, welcome to 5.02. I hope that spring break is going well. As a reminder, this is building off of what we've gone over in 5.01. So if you would take a few minutes, I think it'd be very helpful to just pause the video right now, go back and look at 5.01, look at your notes. If those are seeming confusing, go back and watch 5.01 again. Make sure that you understand kind of the basics of exponential functions, right? What happens when you raise 2 to the first power, then to the second, then the third, so on and so forth, and how that will look on a graph. And then once you've done that, go ahead and continue on here. So what we're going to do is we're going to really dig down and decide what happens when certain pieces of an exponential function change, and how we can use that to help us quickly understand what a graph of an exponential function will look like. So this should look familiar, right? An exponential function is a function where the independent variable is in the exponent. And there are some different constants that we can change, right? We can change the base of the exponent. We can change what we're multiplying that exponential expression by, that's the a value. We can change what we add on to the expression, the c value. And we can also change the k value, meaning we can either subtract or add to the exponent, which will have an effect on the expression, the graph of the function as well. And so our goal is to say, okay, when a, b, k, and c, when they're changing, what effect will that have on the graph? And to help us with this, we can kind of just think about a really basic exponential function, 2 to the x. What does that look like? And it's a pretty basic graph. We graphed it using a table and thinking about the values. And you are more than welcome to continue using a table, but remember, that's not going to be the most efficient way to graph these functions. What's going to be the most efficient way is to be able to recognize what the a, b, c, k values, what those values are, and say, okay, this is what I'm expecting to happen to my graph, and then plot a couple of points, just that are easy to plot without creating a table, and that will allow us to look at the function much more efficiently. So pause the video now, and what you want to do is, for each of these constants, you want to decide how they affect the graph. And I'm not going to give you too much direction here because I want you to explore it on your own. We talked about how you can test these, right? So for example, if I want to test the difference between two different a constants, I can keep the b value the same. So I could use 2 to the x, and I could change the a constant. Maybe I multiply it by 3, maybe I multiply it by 4. See how that changes the function itself. And that will give me an idea of how that changes the way the function looks. Okay, so pause the video, go ahead and do that for a, b, k, c, and when I say x/-x, that's talking about the difference between a function. So if I have 2 to the x and 2 to the negative x, what is the effect of having this be a negative exponent? Alright, so the first one is the a value, and you can play with this a little bit, obviously using Wolfram Alpha, and if I increase the a value, to something like 5 or 10, it'll make my function steeper, right? Just think about that. If I multiply something by 5, it's going to be 5 times greater. And so when I multiply successively bigger numbers by 5, those values are going to get bigger and bigger and bigger. Similarly, if I use a value that is less than 1, it's going to get shallower, be much more flat. So it might be a good idea to, remind yourself that it will be steeper when the a value is greater than 1. It'll be shallower when it's less than 1. And if it's going to be negative, remember, if it's negative, I multiply something by a negative, that's going to change the sign. So if I have a function that's always positive, for example, 2 to the x is always positive, when I multiply it by a negative out front, everything is going to be negative. So it would now look like that. Okay, continuing on now with the b coefficient. Right, for the b value, this one there's a couple of things that we want to notice. The first is thinking about when the b values are greater than 1. So, think about just 2 to the x, right? This b value is 2, it's greater than 1. And what happens when you raise a number that's greater than 1 to bigger and bigger powers? Well, it's going to get bigger and bigger, right? Which is why as x approaches infinity, as x moves further and further to right, I get bigger and bigger values, right? And as x gets more and more negative, I'm taking the inverse, right? That's what negative exponent does. And so I'm getting closer and closer to 0. So as the b value, pending it's bigger than 1, and we'll talk about what happens when it's less than 1 in a second, but so long as your b value is bigger than 1, this is always going to happen, and the bigger your b value gets, like for example if I had 3 to the x, it would be more steep. And so as b increases, your graph will get more and more steep. But what happens if you have a b value that's less than 1? And we talked about why a negative doesn't quite make sense. Because when you have a negative number raised to even powers, it'll be a positive number, and raised to an odd power will be a negative number. So that doesn't make as much sense. So we'll just imagine that b is still greater than 0. But what if it's less than 1? What if it's like 1/2 to the x power? Well, think about this. When you have a number like 1/2 to the x power, let's just pretend that was what we were dealing with. 1/2 to the x power. Well, the bigger your exponent gets, the smaller your value is going to be, because you're multiplying 1/2 by itself over and over and over again. So here, the way that the function works changes. It sort of reflects itself. So now, as you're approaching, when x is getting closer and closer to negative infinity, meaning moving to the left, your function is going to approach infinity. Meaning as I move to the left, instead of getting closer to 0, it's going to get closer to infinity. We talked about that a little bit before the break was over, and I encourage you to try this. See what happens if you were to do 1/2 to the negative 10. Okay? Go ahead and try that out and see what you get. And you're going to get a very big number. You're going to get 2 to the 10th. So you're going to get very big values as you move to the left. And as x gets closer and closer to positive infinity, this says x approaches positive infinity, means moving to the right, you're going to get closer and closer to 0. So your function will look like this. It'll just reflect across the y-axis. All right, now let's move on to k. So for k, this one's actually pretty easy for us to think about. It's either going to translate left or right, and the easiest way to think about this is to compare 2 to the x to 2 to the x plus 2 and 2 to the x minus 2. Notice both of these are all in the exponent. When I have 2 to the x, 2 to the 0 is just 1. That's an easy thing for us to kind of think about and see what happens to that point here. And that's when the exponent is 0. Well, imagine that you had 2 to the x minus 2. What would your x value now need to be so that you had 2 to the 0? Well, it would have to be 2. So only when your x value was 2 would you actually have this value, this output value of 1. So you'd have to slide this point over to the right 2 units in order to get your value of 1. So 2 to the x minus 2 is translating your function 2 to the x to the right 2 units. And so when I see an exponent where I have x plus or minus something, I can think about that either sliding a graph to the right or to the left by thinking about where this point where I end up with 1 or an exponent of 0 is going to happen. And that's always what we like to think about. Where will the exponent be 0? Because that's easy for us to compute, right? Anything to the 0 is always 1. So if I can find where is that value going to be, where's my exponent going to be 0, then I can plot a point pretty easily. And the same thing happens for 2 to the x plus 2. Here I need an x value of negative 2 over here for me to get an output of 1, or 2 to the 0 power. C is very straightforward. Here I'm just thinking about either adding something or subtracting something. Certainly if I'm adding the same number at each point, then it's going to move upward, and if I subtract the same number at each point, it's going to move downward. So this is going to translate either up or down. Quick example, I could have 2 to the x plus 4 or 2 to the x minus 4, and one is going to be translating upwards and one is going to be translating downwards. Okay, for the difference between having x be positive and x be negative is a reflection. All it does is reflect across the y-axis. And to help you see this, you should graph both 2 to the x and 2 to the negative x. And you'll see how this changes. And I will actually go through this kind of quickly here. So I'm going to graph 2 to the negative x in red. So let's start with 0. Negative 0 is just 0. So the same point occurs right here. But now let's think about what happens when you move towards the right. So if you have a positive x value. So for example, 2 to the negative, and x is positive 1, so it would be 2 to the negative 1. Well, 2 to the negative 1, I'll do this only one time, 2 to the negative 1. Remember, a negative exponent means I take the reciprocal with the positive exponent. 2 to the, I should have made this 2 to the 1, so 1/2. So here as I move to the right, my function is going to decrease in value, and it's going to continue doing that. Imagine you had 2 to the negative 2. That's going to be 1/4. And it's going to work downward like that. But as I move to the left, as I get negative x values, so imagine x were negative 1. Then I have negative 1, which is positive 1. And 2 to the positive 1 is 2. Imagine I had x be negative 3. Well, negative 3 is positive 3, and 2 to the positive 3 is 8. And it will look like that. And notice here that the points that 2 to the x had for positive x values are going to be the same as the points that 2 to the negative x will have for negative x values. And so you can see that it's just a reflection across the y-axis. Important big picture thing to remember is that we always want to keep in mind what is happening to this, these different end results. So with an exponential function, there's always going to be one direction in which it's increasing, and there's always going to be one direction in which it's getting closer and closer to a value, but never quite touching it. So 2 to the x, as I move towards the right, is going to get bigger and bigger and bigger, and as I move towards the left, is going to get closer and closer to 0. And we want to keep track of what's happening there. So for example, imagine your c value changes. That means everything translates up or down. Well, if I translate this up 4 units, now instead of it getting closer and closer to 0, it's going to move closer and closer to positive 4, since everything has translated up 4 units. Okay? So we got to keep that in mind as we go through. Now, don't worry about not memorizing this yet. You have this now. You can go back and you can remind yourself what happens as the a value changes, and you can say, okay, I should be expecting something to get steeper or more shallow. And now you have a way of checking that your graph is correct. Okay? You may still want to use a table. That's fine. We're going to move closer and closer to being able to just think about how this transformation will change our function, and then go right into graphing it, and that will come with time and experience. Right now, what we're going to do is we're going to get some practice. So this is going to be a little bit of a long video. That's okay. You have plenty of time to do it. We're going to have we're going to graph a couple of functions, and then I have a few questions for you that are a little more in depth. Okay, so here we go. So to start off with, I want you to graph each of these functions on the same graph, so the same XY graph, and you should label them. So there's a lot of different ways to think about how you can start doing this, and here's what I want you to do. Remember that we talked about how much more efficient it is to not have to create a table every time that I want to graph a function. So I want you to try that first, okay? So for each of these functions, what you should start by doing is looking at the function and saying to yourself, okay, what are the different a, b, k, and c values going to do to my function? Decide what that's going to do, okay? So I'm going to walk you through the first one here. I have a b value of 3. So I'm thinking, okay, that's going to be a little steeper than 2 to the x, right? 3 to the x means I'm multiplying by 3 over and over again. And so that's going to be a little steeper. Okay, good. I have an an a value of 2, so that's going to make it even more steep. And then I have a negative out front, so negative 2, which is going to reflect it across the x-axis. So if I'm just in my head thinking about this, I know that instead of moving steeply like this, it's going to move steeply like this. So all of a sudden I have this in my mind, and now I know what I'm expecting. So now I can start thinking about really easy values. So let's just think about 0. Well, 3 to the 0 is 1. So negative 2 times 1 is going to be negative 2. So all of a sudden I have a point down here, and this, it depends how what I want you to do is you should actually mark off, the value. So maybe you say this is going to be 2 and this is going to be negative 2. And you might want to make your graph bigger in this case. But here I have a point already, right? And I know that it's going to move down like this and approach 0 over here. And then I can plug in a couple more points, so when x is 1, I have 3 to the 1, which is 3. Negative 2 times 3 is negative 6. And here I am. And now all of a sudden, I have a good idea of what this will look like, okay? And so that would be f of x. Now, if that's challenging for you, after you've done that, if you still are not sold, you can create a table of values. Here's the x value. What's my corresponding f of x value going to be? So for example, when I plug in 0, I will get negative 2, right? And I plug in 1, I will get negative 6. If I plugged in negative 1, I would get 1/3, negative 2 over 1/3, right? So think about what that would be. It would be negative 2/3, right? And that makes sense because I should be getting closer and closer to 0. You can do this for each function. You might want to, start to wean yourself off of it and really try to do it without creating a table, but that's perfectly fine. Whatever you need to do to make sure that your graphs are correct. The last thing I'll say about this is for each of these, you want to make sure that they make sense in relation to the other, right? So if you had a function which was translated up 4 units and a function that was translated up 6 units, you want to make sure that those are in the correct space relative to one another. Okay? So graph these out. This will be good practice for you. Remember, you can check your work. So you can go to Wolfram Alpha and you can actually check each of these. You can graph them all at the same time and make sure that what you've gotten matches up with the correct. Now, I obviously want to make sure that you graph these by hand first, because if you go straight to Wolfram Alpha, you're not actually learning, and then when the test comes around, and there's no computer available, you're going to be out of luck. All right, so go ahead and get these done. Check your work on your own, and then there's a few more questions for us to look at. A couple more questions to take a look at. One is very straightforward. I do want to talk briefly about number 2. So here we're given a function p of x, and a and b are not told to you. You have to decide what has to be true about a and b so that these characteristics can be the case. I'll talk briefly about what this means. So the characteristic of the domain is all the possible inputs, or x values, and for this function, p of x, it can be any real number, all real numbers. So you want to make sure that your function works so that you can have any x value is, doable. The range is, of course, all the possible outputs, all the possible y values. And for this function, p of x, all the possible y values are y values that are less than 0, meaning they're always going to be negative. So your function is going to live in negative land, right? There's never going to be a case where it's in a positive value. And then the next characteristics is what happens as x approaches positive infinity, meaning as x gets further and further to the right. For this function, y is going to get closer and closer to 0. So remember, your range is always negative, so it's always negative. And as I move towards the right, it's getting closer and closer to 0. Then as x approaches negative infinity, meaning as you move towards the left, y is approaching negative infinity, meaning as you move towards the left, your output is getting more and more negative, approaching negative infinity over here. So you now have to decide which of these possible options is going to allow for this function, p of x, to have these certain characteristics. Okay, there's one more for us to look at, so pause the video, try these out, and then move on to the next one. Last one here, you want to match each function with the graphs below. So for example, if you were to think that number 1 matches up with A, you want to match it up like so. Okay? I'm not saying that's the right answer. I'm just putting it randomly there. Now the key here is not to actually graph all of these out. You can think about how they relate to one another. Think about the A and B values. How will that change the graph? And look at the graphs here. They all relate to one another. So for example, if you look at 1 and 2 here, they have different B values, the same A value. What will be different between them based on their different B values? And then once you've decided that, that will help you pinpoint which of the functions, which of the graphs 1 and 2 could be by relating them to one another. Okay? So go ahead and give those a try. Have a great rest of your spring break, and I will see you guys next week.